Good morning, good afternoon, or good evening. My name is Kaylea Bixler, and I am a second-year medical student here at the OSU College of Osteopathic Medicine. And today I'll be presenting my summer research project, which is titled A Statistical Analysis of Medical School Exam Score Distributions. Before I hop in, I want to acknowledge my co-authors, my collaborator, Nick Sajati, and my principal investigator, Dr. Joseph Price from the Department of Pathology. So we'll get right to it. So mean, median, and standard deviation are key players in any basic statistical analysis. And those utilizing descriptive statistics have long used these three integral components to draw conclusions and identify trends from large-scale data sets. However, very few have actually endeavored to use this method when it comes to medical school exam score data sets. So the aim of our study is actually threefold. First, we want to obviously determine these basic statistical measures among the exam scores we were given. Second, we want to graphically explore mean, median, and standard deviation and see if there are any trends that we can observe from the graphs. And third, we hope to provide useful metastatistics to not only better understand medical school exam performance, but also hopefully provide useful curriculum suggestions if they are needed. So how did we do this? Data from the 2019-2020 academic year was collected from all exams that were given to first and second year medical students here at OSU Com, and were grouped according to various identifiers in Microsoft Excel. This data was subsequently input into the software suite R, which is a data visualization framework for all of our subsequent graphical and numerical analyses. So our first step was to validate our use of a graphical approach as a numerically sound way to be drawing these conclusions and observing these trends. So the first thing we did in figure 1, as you'll see, is we took all the exam scores that we had and input them into this scatter plot. So obviously that's a lot of data points. So we added a bit of randomization gauge point to prevent our overplotting and added a histogram to look at the concentrations of where exam scores are. So just visually looking at the graph, it appears that the highest bar is somewhere around 85. And when you go to table 1 in our summary metastatistics, we see that the average mean for all exam scores was in fact an 84.2. So by this, we know that looking graphically at this large scale data set actually can yield some useful and statistically sound results. So further, one of the groupings that we tried was systems versus non-systems exams. So the way our curriculum is set up, we take both non-systems courses and systems or human body-based courses that largely take up most of our second year. And so we separated all these scores into whether they were from an exam from one of those systems courses or not. So figures 2, 3, and 4 all adhere to the legend you see at the top, with the non-systems exams being plotted in teal and the systems plotted in orange. So 2, 3, and 4 are displaying both the mean, median, and standard deviation per exam with the name of the exam listed on the y-axis. So as you can see, just looking at them, orange is a bit more tightly clustered than blue. So system is a bit more tightly clustered for all measures of central tendency and variance than the blue figures, which lends itself to some interesting conclusions. So as I mentioned, they do appear more tightly clustered in terms of mean, median, and standard deviations. And that lends itself to a further exploration of whether or not the systems course exam grades actually correlate between a value of normality, or that bell-shaped Gaussian curve we all expect to see from an exam. Additionally, we saw that our non-systems exams show a lot of variability when it comes to the measures that we tested them on. And once this test assessed for statistical significance and skewness could indicate a need to restructure some of these courses in order to decrease the unexplained variance that we are seeing in the exam performance. So for future directions, we obviously hope to determine numerically the statistical significance of the conclusions that we've drawn from our graphical analysis, and continue analyzing the tested measures with further course distinctions. So in this study, we use systems versus non-systems exams. However, there could be interesting conclusions to be drawn from first and second year courses, or potentially even courses that were taken in a normal learning environment versus our COVID-19 distance learning environment. So there's a lot of different directions we could possibly take this. Finally, we hope to analyze the normality of the exam score distributions for our data set, as well as analyzing the skewness and kurtosis. So these interesting questions we came up with at the end were actually answered further in the summer by my collaborator, Nick Sajati. So I would point you to his project to get some answers on some of these questions that we brought up. And finally, we hope to continue using this analysis annually from different exam score sets to help further shape our curriculum decisions. So as we said, this kind of data can hopefully show us the trends our students and how they're performing in each course. And hopefully that could lead to some quality improvement projects as far as understanding which courses need a little bit of help in terms of getting a more predictable result on their exam scores. So that is all I had for you today. If you have any questions, please feel free to contact me at the email or phone number below. Again, I appreciate all your time and thanks for letting me present today.